All right, let's do some interesting problems. So I'm imagining this one will probably cause some connection. So there, you can watch this video, and essentially this video, he uses a water to measure the volume of a gold chain. And so if the water level was 15 milliliters before putting the chain in there and 20 milliliters after putting the chain in there, then we can assume that there's like 5 milliliters of volume to this gold chain. So let's go ahead and write that down. 5 milliliters is the gold chain. Gold chain. Okay. And then weighing the chain, the mass is 68.7 grams. So we could say this is like the volume. Okay. So he believes that the chain is solid metal, but maybe it's some blend of gold and some blend of other metals. So gold has a density of 19.3 grams per milliliter. Right, gold density, just write that down. 19.3 grams per milliliter. And other metals like silver, copper, the things that are usually blended with gold have a combined density of about 9.7 grams per milliliter. Let's say other metals density. So the question is, what percentage of the chain is gold? And we'll determine that by mass to at least 1 decimal place. Okay, so part of the chain is going to be gold. Part of the chain is going to be other stuff. Let's find out how much is gold and how much is other stuff. So if the second we know that that's what we're trying to find out, those are going to be our variables. So we could say, let X be the grams. Let X be the grams of gold in the chain. And there's multiple ways of doing that. You could let Y be the grams of other metals in the chain. Then what do we know from all this information? Well, we know that the chain is 68.7 grams total. So X, the grams of gold, plus Y, the grams of other metals, have to equal 68.7 grams. What else do we know? Well, we know that the volume of this chain is 5 milliliters. Now this is one was a little bit more interesting. We're going to have to use the density. Let's approach this problem a little bit differently. If we have X grams of gold, and the gold density is about 19.3 grams per milliliter. Oh, we got a bit of an issue here. Okay. Because if X is gold, we can't just multiply them together. Why? If we multiplied it X by the 19.3, we'd be multiplying grams by grams per milliliter. We get like grams squared over milliliters or something. It'd be weird. So I don't know the solution to this problem, but just kind of talking through it myself, what makes sense to me is we know that the whole total has to be 5 milliliters. So let's try to get something about milliliters. So likewise, we could flip this and say that 1 milliliter of gold is 19.3 grams of gold. Right? That would work too. And then notice, what is X times this number? X grams of gold times that, the grams will cancel, we'll get milliliters. So that'll work for that second one, right? If we have X grams of gold, and we know that 1 milliliter of gold is 19.3 grams of gold, the grams are going to cancel, and we'll have X milliliters. So if we want to know how many milliliters the gold takes up, we just found it. We can do the same thing to find out the other one. So we're going to have 1 over 19.3 X plus the same thing for other metals, 1 over 9.7 times Y. We know that has to be 5 milliliters. Now we have a system of equation that we can solve. Might be a little bit messy, but We'll listen to Shia LaBeouf and Arnold Schwarzenegger. And we will just do it. So we could use elimination or substitution. A few different ways of doing that. Elimination looks, they're both pretty bad. All right, again, addition or substitution. I keep saying elimination. I'm going to solve for y in this first equation. That means y is going to be 68.7 minus x. And we can plug that in for the y in the second equation. They give us 1 over 19.3 times x plus 1 over 9.7 times y, which is 68.7 minus x. That all has to equal 5. And we'll simplify. 1 over 19.3 times x. When we distribute, what is 16.7 divided by 9.7? That's about, okay, we are going to approximate. I'm going to include 4 decimals here because I don't want to have a lot of rounding error. 1.7216. Minus 1 over 9.7 times x equals 5. Let's subtract this from both sides. And there's probably a cleaner way of doing this problem, but there's a lot of different ways of setting it up, and this is the way that makes sense for me. All right. The right-hand side is going to become 3.2784. Now we just combine the x's and then divide. Okay. So we'll go over to here. What is 1 over 19.3? We're subtracting 1 over 9.7. That's about negative 0.05128 x's. That's equal 3.2784. And now we just divide. And I'm going to get a negative number, which makes me real nervous. It's because I plugged it. It should be 68.7. That's 7.0825 back here. 7.0825 is this guy. 7.0825. And that's what we subtract from both sides. And when we do that, we're going to get something a little different. When we subtract that, we are going to get negative 2.0825. Negative 2.0825. And we'll divide those two numbers. And now we'll get a positive number, which makes me a lot happier. Okay, so, and again, just to double check, right? 5 minus this is negative 0.0825, just like I thought. Now we have negative 2.0825. We're dividing by negative 0.05128. And we're going to get about 40.61 grams. Okay, so that's about how much grams of gold we think. And again, 68.7 grams was the total. So we don't even have to find y necessarily, right? What is it asking? What percentage is gold? So we know it's 68.7 total. So if it's 40.61 grams of gold, what percentage gold is that? Well, 40.61 divided by 68.7, what percent is that? This number that we just found divided by, I don't want to mess this up again, 68.7. Is about 59.1% gold. Let's see if it likes our answer. 59.1%. We got it. All right. I'm curious if someone did it a different way, because this is the way that made sense to my brain, but it was pretty messy. There may have been a cleaner way. I'm curious what you think. Hopefully you tried it yourself. Hopefully it was a cool problem. It's a fun problem, but it's a little messy. And that's one of the downsides of math, right? If we want clean problems, we can't have real problems. So we want math to apply to our real world, but the problem is the real world's messy. So we get something like this. It's a pretty cool way of solving the problem, honestly, right? He wanted to find out, like we didn't have to use anything fancy. Just essentially a measuring cup. It was a beaker, or a graduated cylinder. I don't know what it's called. We basically had a measuring cup and some water. And we approximated how much of this was gold. Like, that's pretty cool, right? We didn't need anything fancy. We just used math. But the downside is, right, you get some messier numbers. Anyway, I thought that was fun. Let's do some more practice. When hired at a new job selling jewelry, you have two pay options. All right, and the first one is a base salary of $16K, commission of 8% on your sales, and $25K and 2% for the second one. For option A, to produce a larger income, how much are you going to have to sell? All right. I wonder if any jobs actually have these. These are very common math problems. But I feel like it'd be pretty unlikely. If anyone has experience with this, tell me. I feel like, I don't know. I feel like option B, who knows, maybe disincentivizes you to work as hard on sales. I'm not sure. Who knows? So it wants to know, what does it want to know? It wants to know, when is option A better? Okay, so let's find when they're equal, and then we'll go from there. So option A, our money in option A, right? For option A, it's going to be always 16K. So the revenue, call that revenue 1. Oh, let's just call revenue. The revenue is 16,000 plus 8% of sales. And the second one is going to be 25,000 plus 2% of sales. Normally I'd call these revenue 1 and revenue 2, but I'm trying to be consistent with the notation in this class, or in this section, 2.1 specifically, where we're solving systems of equations. So again, you could use substitution, R is already solved for, or you could use elimination, otherwise known as addition. I always get the name wrong, and get rid of the S that way. I actually really like elimination here. Addition. If we multiply this second equation by -4, what do we get? We're going to get -4R equals -100K minus 0.08S. And now if we add this blue one and this blue 2 together, we now have -3R. We now have -84,000. And all the S's cancel. Now just divide both sides by -3. And R is going to be less than 30,000. 28,000? Is that right? I think so. So although this is not very helpful because it wants to know how much we have to do in sales. This is our salary. So we eliminated the wrong variable. Also, I could have just multiplied it by -1 and eliminated the R. I'm not solving this one optimally, but you can solve it in a lot of different ways. So now we use either one of the original equations to find out what S has to be. Yeah, I didn't think this one through. It's been a long day. All right, let's find out what S has to be. Subtract 16,000 from both sides. And divide both sides by 0.08. When you divide 12,000 by 0.08, you're going to get 150,000. That's how much we're going to have to sell in a year, right? It's in a year. We're going to have to sell $150,000 worth of jewelry every year. What is that in a month? $12,500 of jewelry a month. I'm not a salesperson. I actually really don't know anything about jewelry either. I don't know. Maybe that's maybe you can do it. Let me know. That option A will be better if you do that. Otherwise, if you don't think that's going to happen, choose option B for your salary. Have a great rest of your day. Bye-bye.